Welcome to GRE Snacks, snackable episodes about the GRE exam and graduate school admissions. I'm Tyler, founder of Achievable, and we have an affordable GRE course that includes everything you need to ace your GRE exam. A full textbook, videos on key topics, tons of GRE questions that are backed by our memory enhancing algorithm, a built-in study planner and essay grader, and full-length practice exams. You can try it out for free at achievable.me, and if you like it, use the code podcast to get 10% off at checkout. Now, let's get started. So, today we have Matt Roy with us. And Matt, I'd love if you could just introduce yourself. I think that for us, you're pretty famous because you wrote our GRE course for Achievable. But for everybody else, if you could just say a little bit about your background, it'd be great.
Yeah, sure. As Tyler said, my name is Matt Roy. I'm the course author for Achievable's GRE course, and I've been tutoring for the GRE now since grad school back starting in 2020. I started tutoring for Kaplan, then I eventually started tutoring just for myself on Wyzant,
Hmm.
and I'm here now. I'm still writing problems for Achievable's course and still tutoring all the time. So.
Yeah, great. And so today we're going to be talking about a specific type of problem on the GRE Quant question, or not, sorry, not a specific type of problem, a specific tactic for the GRE Quant,
Yes.
which is picking numbers. So what is picking numbers? What does that mean?
Yeah, so picking numbers is essentially what you do in a question where you have some sort of variable or something, some unknown number in a question, and instead of trying to solve for it, and obviously in some cases it's impossible to solve for,
Hmm.
you fill in numbers and just go with those.
Hmm.
And I'll explain why that's like really useful in many cases. But you fill in numbers, you pick them, and then you work on the problem that way, imagining that is the variable. And then from that, you can glean a lot of information in the problem. I'm going to talk through three question types, or you can say like three little categories of questions in which plugging in numbers is going to be your best shot.
Hmm.
Um, the first one is in a quant comparison question, when you have a variable that is unknown, maybe there's a constraint. It says like x is greater than 5, or x is between two numbers, or x is an integer, positive integer, or something like that. That would be the constraint. But it doesn't say what it is. In that case, if quantity A and quantity B both have this x somewhere in it,
Hmm.
and you do something to it, it's like to whatever power divided by 3 or something is going on. Of course, there is no specific value of x, so what you do is you plug in values that fulfill the constraint.
Hmm.
And your goal should be to plug in multiple values that have conflicting results, meaning in one case, where you chose a number that fulfills the constraint, you get something like a is greater. But in another case, where you still follow the rules of what x must be,
Hmm.
you get b is greater,
Right.
or c for the same. In that case, when there's conflicting results, that's when you choose D.
Hmm.
And the first point I want to make about this is this means, if you're using this strategy, that you can't just plug in one number. If you plug in just one number, you never give yourself a chance to even prove D. Why? Because if you have one result, you can't have conflicting results. So you should plug in at least two, three usually.
Hmm.
Um, And if, of course, if you plug in 3 and you still get the same answer, it probably means that answer is correct. So if you got A is greater in all three cases and all three possible values of X, then of course, then you would go with A. Now, you shouldn't just pick any number though. Just like in the other question types that I'm going to discuss later, it's important to pick smart numbers. If the goal is to prove D, meaning prove conflicting results, then you should pick numbers that you believe would give you conflicting results.
Hmm.
So, like, for example, if it says x is greater than 5, don't just choose 6, 7, and 8 and then be done.
Hmm.
There are other number types. If the constraint is only x is greater than 5, we're forgetting 5.1.
Hmm.
It's possible that anything 6 or greater gives you one result, or anything between 6 and 5, that decimal is the other
Hmm.
result. And I should say that when you're proving D, it's always going to be that one little slight thing that you're forgetting that proves it.
Right.
Okay.
Do you also think like you
So
should maybe even instead of doing like 6, 7, 8, you do like 5.16, but then also like 91 or something like something big?
absolutely, that's absolutely what I would do.
Hmm.
You would choose the minimum extreme, the first natural integer, and then a large extreme.
Yeah, and then
Perfect. That's
do
exactly
you
it.
think it matters at all? I don't know. I just this popped in my head. Do you think it matters at all to pick a prime number? Or I feel like prime numbers are not that common, but maybe they are.
It is so it's very relevant what quantity A and what quantity B are.
Hmm.
If quantity A is about, for example, the remainder of something,
Hmm.
then you should pick numbers that you believe would give you different remainders. So, for example, it's like n divided by 7. If for every value that you plug in for n is literally a multiple of 7, you're never going to get a remainder.
Hmm.
So it really depends, problem to problem. You have to zoom out and ask yourself, what might give me unique results? Okay. Um,
Yeah, and then another
there is a
one.
little cheat sheet though.
Oh, sorry.
Uh-huh.
I was gonna say another one is like if possible, picking like -1, 0, and 1, and then like -2 and 2 and things like that. Like those are like those five numbers are kind of tricky in general.
Yes. Yeah, that's the cheat sheet I was just about to
Oh,
say.
okay, great.
So I'll run through them now. Yeah, yeah. So the numbers that you should definitely pick whenever you can, in essence, this little cheat sheet is going to do the thinking for you. If you go through all these, you're probably going to end up picking numbers that have unique um, properties to them that will give you unique results. So 0 is the first one. Plugging in 0 is also the first thing you should plug in for another reason. You don't have to do any math,
Hmm.
and it's really good to get a result fast.
Hmm.
So don't plug in a hard number first, just plug in 0 first. The next number would just be 1. 0 and 1 are probably going to have unique properties when you plug them into problems. For example, if an exponent is the variable, exponent of 0 means that the result is 1. Exponent of 1 just means that the result is whatever the base is.
Hmm.
Um, Obviously, there's like many other cases where obviously 0 and 1 are different.
Yeah, yeah, they're
There's much
special.
more. Yeah. The next one is negative numbers. Negative numbers are going to be obviously important because they just flip the entire problem
Right.
and make it, on the left side of the number line. But also they can be important for problems that have exponents. For example, any exponent that's negative, or sorry, any base that's negative that has an even exponent is still positive, but odd exponent is now negative
Hmm.
or continue to be negative. So yeah, negatives are important. The next one is fractions or decimals. Like I said earlier, like 5.1, I would consider that like a decimal like
Right.
answer. But fractions are really important too. Anything between 0 and 1. Because, like, for example, if quantity A is x to the eighth power and quantity B is x to the ninth power, and it says x is greater than 0 and not 1. Of course, anything to the ninth power seems like it's greater than anything to the eighth power. But if it were
Right.
a fraction when multiplied by itself shrinks. So you want the thing that multiplies by itself
Hmm.
less if you want it to be bigger. So in that case, quantity A is bigger if it were a fraction, but if it were an integer greater than 1, then quantity B is bigger. So fractions are also important to think about. And then the last one is, as you said earlier, extremes. So that could be small extremes or big extremes, depending upon the constraint. But don't forget to plug in like a big number, just in case quantity A, for example, is always greater than quantity B when you plug in small numbers, but then going really far down the number line, suddenly it, you know, jolts up. That could be the case. So you want to plug in a really big number just so you can kind of cover your bases and just get way out there to see if ever it does
Right.
change
Because you could,
the
for
relationship.
instance, be comparing like I don't know, 100,000 X versus, you know, 2 to the Y. And it's like, essentially, if Y is big enough, it will be bigger.
So it will eventually pass
Yeah. Or I guess it'd be 2 to the X, but same idea.
to
Yeah,
the
yeah.
X. Yeah, but it will eventually pass. Yeah,
No, that's
yeah. It'll take a little time, but it will.
yeah, that's very cool. Yeah, I think quant comparison is probably the one of the best places to do this strategy.
Hmm.
And they're
Um,
also one of the most annoying
I
problem
would just want
types,
to say,
so it's helpful.
yes, I just want to say like how important it is to kind of zoom out and ask yourself what numbers would give me unique results. And that the point I want to make is that like some problems there are two variables. And so this zero one negative fraction extreme thing gets even more complicated because if you have two separate variables you're plugging in, what do you do? Do you do like, a negative for both or fraction for both or extreme for both? And the answer in most cases is no. A You want a unique pair. So for example, one time you might pick an even number for both. Another time you might pick one that's even, one that's odd, and another time they might pick something else where both are, oh, sorry, I meant to say positive or negative. Um, you might choose a situation where they're both positive, one situation where one's positive, one's negative, and then another situation where they're both negative. That would be a situation that would give you most likely um, the chance that would give you the highest chance to get unique results. It would be bad if you chose just, two zeros, two ones, two fractions, two extremes. It's the relationship between the two that gives you you know, the uniqueness or the character.
Mhm.
So I just want to say that there, um, sometimes it's about the relationship between the numbers that you plug in, not necessarily just what the numbers are, but how they are relative to each other. That's an even a deeper level. So
Mhm. Great. Yeah, then so what's the second problem type?
yeah, so the second problem type is going to be a word problem that involves some sort of variable. Sometimes it explicitly says it's a variable. Sometimes it just says like a certain amount of. So it doesn't actually say variable, but it really is. And the answer choices also are non-specific. So the answer choice might be something like C times D over B. And in the actual question, they say there's C amount of apples and D amount or sorry, C amount of apples and they cost D. And the total cost is C or something, I don't know, something like that. And the question would be something like, what's the cost per apple? Or like,
Yeah, like it's like the fence
what is
question
the,
type, right? Where it's like a fence costs 12.95 per 6 feet, and you have to,
Mhm.
build it in a hexagon, and the hexagon has an area of this, right? Like or something like that.
But instead of it even saying it's 12.95 per square foot or per foot, it literally just says it's X per square foot or per foot.
Right.
And so the answer choices are also in terms of those variables that exist in the
Oh,
problem.
okay.
And
Yeah.
so and so the strategy for this, actually the best strategy is not necessarily to figure out the relationship between all these things and then trying to find the answer like whatever it says like X in terms of Y or whatever. One really easy way to solve this is to just plug in numbers, meaning I'm just going to say it's $1 per foot, and I'm going to say it's this many feet total, 10 feet total. Naturally, it would be $10 then. And then with the values that he plugged in for each
Hmm.
variable, 1 and 10 in this case, you would look at the answer choices and you would say, which of these gives me 10? And something would be like, let's say A is the 1 and B is the 10.
Hmm.
A over B is not 10. So 1 over 10 is a tenth. That's not 10.
Hmm.
You would just find the answer choice that is what you're looking for. And you're looking for 10 being the total amount you pay for. So the answer choice would probably be A times B, 1 times 10.
Right.
And then other answer choices, which would be incorrect, would be like B minus A or A minus B. And So instead of even understanding like what these variables are in relation to each other, literally just plug in and always plug in super simple numbers. Okay.
Hmm.
One thing I do want to say though is not to plug in um, repeated simple numbers.
Hmm.
So if you plug in one for everything, you're likely going to get some false positives. So like A over B is the same as A times B if they're both one.
Right.
So you need to have some uniqueness in the numbers you've chosen, but not a lot. They need to be simple and they just they need to be simple and unique, and then you're going to find the answer. And this is another point I want to make. There is only one answer that is correct,
Right.
meaning literally whatever you plug in, it must get you to the answer. You don't have to worry. Um, so a lot of people get scared when they plug in. They're like, "But I don't know how much it costs." Well, there's actually nothing. No one knows. So you might as well just plug in the the point is that the answer choice is about the relationship between the variables. So you don't even have to care what you plug in. You plug in something as long as it internally makes sense, then it's fine. So
Well, and as
you
long as
plug
it
in
makes
very
sense in the
simple
context of
numbers.
the problem too. Like if you're buying fence
Yeah.
segments, they're not going to cost zero and they're not going to cost negative, right?
Okay, that's
Yeah.
true.
So
Yeah,
you
of
can
course.
narrow it down a little bit that way.
Yeah. I will say though, if you plug in numbers that aren't unique enough, you are likely to get false positives. So you might get two answers that work, which is okay. All you need to do at that point is to just think of two other, or to plug in a little bit more,
Right.
plug in again, another unique set, and then only plug it into the two answer choices at that point that you got positives for. And then one of them will likely at that point uh, be eliminated.
Hmm. Great. That makes sense. And then on to the
Um,
third one,
yeah,
if you're ready.
yeah, yeah. The third one is it's another word question. Anytime there's a word question that involves percentage change, the best number you should plug in is 100.
Oh, yeah.
And that's because like obviously a 20% increase of 100 is just 120. You don't even have to use the calculator, right?
Hmm.
And then like another 20% increase would
144.
be
I
yeah.
don't know why, but
And
that one's
then
always been one that I knew
if
for some reason.
if the initial question then is by what percent did you increase from start to end, it's really simple. If you started out with 100 and then you ended up with 44 more, then it's a 44% increase. That's also why it's really important to just start with 100 because the end answer becomes really easy. Of course, it works the same for percentage, like decrease as well. Like, 10% decrease from 100 is just 10 less, so it's 90. So that's why it's like really important to just plug in 100 for percentage change problems. Um, I will say though, if this percentage change is a multiple of 10, it's like 20%, 30%, whatever, then you can plug in just 10 because you're still going to get a whole number. Um, but in general, just plugging in 100 is the best. So,
Yeah. Great. Yeah, and the nice thing about that too also is I mean it just like makes it a percent.
yeah, yeah, exactly. It makes the last part really easy because if you plugged in something like 17 to start,
Hmm.
and then you got your increase, then a decrease, then whatever. In the end, you still have to do the end result over the 17 to determine what percentage of the original you have.
Hmm.
But with 100 initially, it's just there. You just have to look at it. You don't have to do any math.
Right. Exactly. Great. Any other thoughts on this before we wrap up?
I don't think so. I would just say use this in practice. That's the key. Um, it's one thing to know all this, but for the listeners, definitely try using it when you see a problem that you think it would be applicable to.
Hmm. Yeah, great. Thank you so much. This has been GRE Snacks, hosted by Tyler from Achievable with Matt Roy. And Achievable has a great online GRE course that you can try for free at achievable.me. and use the code podcast to get 10% off at checkout.